everybody. Welcome to our notes about ocean currents. We're splitting this up into two different parts. The first one being surface ocean currents. SWABOT! Students will be able to describe how surface currents are formed and describe the role of the sun in forming currents. All right, so here we've got our 5 oceans. And while there's really only one ocean, we name oceans based on geography. And from largest to smallest, we've got the Pacific, Atlantic, Indian, Southern, and Arctic. And this is kind of an interesting view from like the South Pole-ish, looking upward at the different oceans. And then there's just a little picture of like, but really it's only one. It's not like we have fences or walls between the oceans. All right, so there's a more traditional look at the oceans. You can definitely see in this picture that the Pacific is the largest. Atlantic is next. All right, water on Earth, before we really start talking about the oceans. Of all the water, or of our planet, 71% of it is covered by oceans, 71%. So that means only 29% is covered in continents. But of the water, 97% of all the water on the planet is in the oceans. And that means 2% is fresh water in glaciers and ice caps, so like Antarctica and glaciers, floating pieces of ice. And that means only 1% of our water comes from lakes and rivers and aquifers, which is water underneath the ground. But the saltwater oceans are very important. We don't talk a lot about the water cycle in 6th grade, but basically we need evaporation from the oceans, and that's how we get rain and snow and all kinds of other stuff. Is we need that evaporation from the oceans to get our fresh water. All right, so surface ocean currents are it's like basically flowing water in a particular direction, and they are mainly caused by wind. Warm water is moved from the equator towards the poles. So remember, the equator is in the middle, and we've got warm water sitting at the equator, and that warm water gets pushed around towards the poles. And we've got cold water from the poles that gets pushed up towards the equator. So currents really help move those different temperature water around. Now, because of that, currents help to regulate our Earth's climate, which is more than just weather. It's how warm is different places, and those currents help change what would maybe be a different kind of climate if we didn't have that. So without currents, temperatures would be more extreme. In the equator, it would be hotter than it is now, and in the poles, it would be even colder than it is now if we didn't have warm water coming down to the poles and warm water leaving the equator to heat up other parts of the planet. So if that was the case, we would have less usable land. All right, the next thing we want to talk about is called the Coriolis effect. And the Coriolis effect is that the Earth is spinning on its axis, so it's turning around. And if we had wind that wanted to move upwards, because the Earth is spinning, it's going to deflect that wind or air to the right in the northern hemisphere and to the left in the southern hemisphere. And I just put a quick little sketch up of currents up here, you can see how in the northern hemisphere we've got currents going this way, which is like this, and in the southern hemisphere we've got currents going this way, and that's because the Earth is spinning on its axis. So the surface currents follow this pattern because the winds move in that pattern because of the Coriolis effect. All right, I want to give an example of a particular surface current, which is called the Gulf Stream. So in the Gulf of Mexico, we get the origination of the Gulf Stream. So it's warm water, and it moves up the eastern United States and then goes on to Europe and England and Iceland. And this brings warmer temperature than would otherwise happen in this area because of this warm water current that moves this way. All right, what is the sun's role? What would the sun have anything to do with our oceans? So basically, I want you to think about the sun is heating the Earth, and it is particularly heating the oceans at the equator. And those currents are distributing that heat around the Earth. So unequal heating, I'm going to go back to a little bit of something we've learned about already, which is convection. So remember, we've got warm air that rises and cold air that sinks. We've really talked about this in the mantle and in particular. But in currents, for wind, we've got warm air rising and cold air sinking. And so when we have that, it creates wind. That the air is moving, and that high pressure and low pressure, I'm sure you've heard on the weather, it creates wind. And that wind is what creates currents. All right, so I want you to look at this image and think about, why do you think the ocean would be warmer at the equator? Why would the equator be warmer in general on the continent or in the oceans than the poles? So take a second to look at this picture, pause the video if you need to, but how can you explain why it's warmer at the equator than the poles? All right, reflection questions. What causes surface ocean currents? How do surface currents affect temperature and or climate around the globe? And what is the sun's role in creating currents? We've got our meme of one ocean waving to the other ocean. And as I always say, science rocks.